And here is the answer. I will give the general form. So we take the derivative of the utility function with respect to a. So taking that, we are just left with the b. And if we take the derivative of the utility function with respect to b, then we're just left with the a. And we know that the marginal rate of substitution is equal to the ratio of the marginal utilities. So we have that the marginal rate of substitution is equal to the marginal utility of A, which is identical to B, divided by the marginal utility of B, which is equal to A. That's the general form, so we did not use the specific consumption bundle that was given, but we know that at this particular bundle we had 5 bananas and 4 apples, so we plug in these two numbers and we get that at this particular point of this consumption bundle, the marginal rate of substitution is equal to 5/4. And the slope of the indifference curve must be the negative of this, so the slope of the indifference curve is minus 5/4. Okay, and now we are going to introduce constraints. So far constraints didn't matter. We only looked at preferences and the translation of these preferences to utility functions and derived from that indifference curves and marginal rates of substitution. Now we are going to introduce something that we all face, a limited budget, and also the prices of the two different goods. Now this is an example from the newspaper showing you that if the income changes, that many people also change the consumption bundle that they consume. So one impact of the abolishment of the basisbeurs, the student finance, was that the students had a lower income and their beer consumption went down. Currently there is talk that the new government will reinstall this basisbeurs, so we will see whether as a result of that the beer consumption will go up again. But not only income changes induces changes in the consumption bundles that people consume, but also if the price of one or both goods changes. So one example here, in England a couple of years ago there was a tax introduced on plastic bags, and it was a small tax of only 5 pennies, but because of that consumers, they no longer bought plastic bags. So the usage of those bags dropped by 85%. And this is really an example how prices and the market mechanism can also be very effective in reducing pollution and helping the environment. However, consumers can also be very smart and outsmart the government and avoid taxes. So what happened in Norway is that in Norway they imposed a sugar tax onto consumers because eating a lot of sugar is bad for one's health and the high health costs will soar. Now, did the Norwegians drop their consumption of sugary goods? Maybe to some extent, but they found also a way out. They went shopping to Sweden, where there is no sugar tax. So in part, they could avoid the tax. And this also shows you the power of incentives. If you impose a tax on something, people will spend effort in finding ways to avoid the tax. Now, how do we feed the income constraints that consumers face into our program? A consumer has a certain income, which we denote by income, and the consumer can spend this on the goods that are available. And in our simple economy, there are only two goods available, good X and good Y. And we also assume that the consumer doesn't save. So we only have a one-period model. We don't consider that the consumer may leave some money in a bank account for future periods. That's all part of follow-up courses. So the income can be spent on good X and good Y. So he can buy QX units of good X, and his total expenditures on good X will be the number of units that he buys times the price per unit. And then there's some money left that he can spend on good Y, and in total he can then also buy QY units of good Y times the price per unit. So, and to find the slope of the budget constraint, we will solve this equation for QI. Why is that? Well, because we have good Y on the Y-axis, the number of units. So we want that to have on the left-hand side of our equation. So we can solve this expression for QI just by bringing the Px, Qx to the left-hand side, such that the minus sign will be added, and then dividing all terms at the left-hand side and the right-hand side by pi in order to get rid of the py over here. And we are left with qi is income divided by pi minus px times qx divided by py. And that gives us the slope of the budget constraint. So it also tells you that if we don't consume any units of good x, so qx is equal to 0, then we are at the intersection with the y-axis, and that intersection is equal to the level income divided by pi, because this term cancels out as when at the intersection qx is identical to 0. Now, returning to the socks and t-shirts example, suppose that the consumer has $50 of income and the price of socks is equal to 5 and the price of t-shirts is $10, then plugging in all the elements into this equation gives you the following expression for the number of units of t-shirts that will be consumed. So, and 5 divided by 10 is the same as dividing 1 by 2. Then we can draw the budget constraint. So this is actually the equation that is given here. If we plug in qx is identical to 0, then qi should be equal to 5. And that's the point of intersection that we have here. Q0 socks, if you don't buy any socks, then you can spend your entire income of 50 on t-shirts. Well, the price per t-shirt is 10. So in total, you can then buy 5 t-shirts. Other extreme, if you don't buy any t-shirts at all, and you have still your income of 50, then you can buy 10 pair of socks, because a pair of socks costs only $5. So 50 divided by 5 is 10. These are the two extremes, and if you connect these 2 points, you get a green line, which is your entire budget line. And the budget line tells you what the consumer, which consumption bundles the consumer can afford. Whereas before we talked about the wants of the consumer, which consumption bundles the consumer would ideally want to buy. And this is really what he can buy. And of course, we now need to connect the two. So bundles to the left of the budget line are feasible bundles. Given his income, this is what the consumer can afford to buy. And all the points, all the bundles to the right are the infeasible bundles. He cannot, well, he can dream about it, but his income doesn't allow the consumer to buy those bundles. And the slope of the budget line is identical to the ratio of the two prices, px over py. In this case, it is minus 1/2. So, meaning that if you give up one t-shirt, you can buy 2 additional pairs of socks, because the price of the t-shirt is twice the price of a pair of socks. Keep in mind that in the end, we want to know how consumers change their optimal consumption bundles when the price of one of the goods changes or when their income changes. But before we arrive at that, we first take the step to look at what happens to the income constraint if the price of one of the goods changes or when the income changes. So we have three situations: the price of good 1 changes, the price of good 2 changes, or income itself changes. Let's go into these three cases. First, we have the situation where we have a certain income constraint, so that the green constraint that is given here, that's the one that we saw in the previous slide. But now something happens, and the one thing that happens is that the socks become more expensive. So we keep an income of 50, and the price of the t-shirts doesn't change. So if we would only buy t-shirts, we would still be able to buy 5 t-shirts at a price of 10 each. So the point B stays where it is. But now consider if you spend all your income on socks. At a price of 5 per pair of socks, you could buy 10 pair of socks. But now the price of a pair of socks has doubled and has become $10 as well, which means that if you would spend your entire income on socks, you can no longer buy bundle A, 10 pairs of socks, but you can only afford bundle A prime, 5 pair of socks. So what happens is when the price of socks increases, the budget constraint shifts inward, and as we call it, it pivots around B. So point B stays where it is, but the budget constraint pivots inwards around that point B. Now the other situation you now already know. The second situation is where we have the old budget constraint, but the price of the t-shirts increases. What happens then? Then we have a pivot around the point A. If you started out with buying only socks, 10 pairs of socks, you don't care about an increase in the price of t-shirts because you can still afford that bundle A. But if you only bought t-shirts, you can no longer buy 5 t-shirts. So you can only buy B prime t-shirts. So apparently here the price of t-shirts has doubled from $10 to $20. So you can only buy 2.5 t-shirts. And all the consumption bundles in between, they were already depicted as the pink area over here. They are the bundles that have become infeasible due to the price change. So you face a loss of feasible bundles. Now these are the first two situations. The price of good A changes, the price of good B changes. Actually, it's very much the same situation. But the situation that's really different is the situation where the income changes. Now suppose that the consumer experiences a drop in income. This is the old budget constraint, but now income has dropped, and that will lead to a new budget constraint depicted here. Note that the new budget constraint now is parallel to the old one. So why is that? Well, we know that the budget constraint, the slope of the budget constraint, is given by the price ratio of the two products. In the picture on the right, the price of the two goods didn't change, so the slope of the budget constraint also cannot change. The thing that has changed is the income. So the income of the consumer has halved, which means that if he would spend all of his income on pairs of socks, the pair of socks still cost $5, but now he only has $25 to spend, so he can only buy 5 pair of socks. And the same with the t-shirts. Previously he could buy 5 t-shirts with his entire income, and now only 2.5. So we have a parallel shift of the budget constraint following a change in income. And now we combine the two. So we looked at the constraints, we looked at the utility functions and the difference curve, and now we put them all into one picture. So consumers, they have to deal with scarcity. They have a limited budget that restricts the number of feasible consumption bundles. And given these constraints, they want to optimize what they buy. And the optimal choice can be most easily interpreted using a graph. So that's what we will do. So we have two goods, good X and good Y, and we want to maximize our utility given the constraints that we face. Now, what are the constraints? The constraints are given by our income and the prices of the two goods. So only the bundles inside the constraint are feasible bundles, and we have to choose that bundle that maximizes our utility. Now, suppose that we have an indifference curve associated with utility level U1. Well, and then all the bundles at this indifference curve give us a certain utility. So for example, we could select this one over here and we would get utility U1. But is this the best thing that we can do given our budget constraint? The answer is no. You can do better. So could you reach a utility level U2 by selecting one of the bundles at the higher indifference curve U2? The answer is no, you can't, because all the consumption bundles at this indifference curve are in the infeasible area. Your budget constraint doesn't allow you to buy any of those bundles. However, you can buy a bundle at the indifference curve U star, because at the indifference curve U star just touches on your budget constraint. So here you have a bundle on the indifference curve U star that is feasible. And that's the one that you would optimally buy given your budget constraint. So given your budget constraint, choosing to buy bundle A is the optimal thing. It's the one that maximizes your utility, and your utility level is identical to the level U star, to the value U star. So to summarize, you pick an indifference curve that's as high as possible while still remaining within the feasible set. So you go upwards, upwards, upwards until you hit the point where the indifference curve becomes just tangent to your budget constraint. And you found the optimal consumption bundle A. So as long as the indifference curve and the budget constraint cross, there's still room for improvement. This was the graphical exposition. You can also do it mathematically, and that is what I will do next. So we've seen that at the optimal point, the optimal bundle A, the slope of the indifference curve is identical to the slope of this green line, the budget constraint. So at the optimal point, we have that the marginal rate of substitution is identical to the price ratio, because the marginal rate of substitution is the slope of the indifference curve, or the negative of it, and the slope of the budget constraint is given by the price ratio of the two goods. So we have that at the equilibrium point, at the optimal bundle, the ratio of the marginal utilities of this consumer must be identical to the prevailing price ratio in the market. And that's the most important result in the lecture today. But it only holds at the equilibrium point. So what does it imply? So let's rewrite the condition. So this is the condition on the previous page, and now we switched actually the px, the marginal utility of y, and we arrive at the marginal utility of x over the price of x is identical to the marginal utility of y over the price of y. So it means that the last dollar that you spend should have the same marginal utility across all products. So suppose that good x gives you 1 unit of x gives you a marginal utility of 6. The price of a unit is equal to 2, which means that the final dollar that you spend on good x gives you an additional utility of 3. Now suppose that the marginal utility of an extra unit of y is equal to 12, but the price of a unit of X is equal to 4, that also means that the final dollar that you spend on good Y gives you an additional utility of 3. So it follows from a model that the last dollar that you've spent on clothing gave you the same marginal utility as the last dollar that you have spent on coffee. So in the previous, we took the budget constraint as given, and graphically we moved the indifference curve outward until the point where the indifference curve became tangent to the budget constraint. We can also do it the other way around. We can try to minimize our expenditures. So we can ask the question, given that we want to reach an indifference curve, what are the minimal expenditures? What is the minimum income that I need in order to arrive at that indifference curve? And this is the dual problem of utility maximization. And we will get to the same result. So an example, suppose that I consume apples and bananas. My utility function is, a Cobb-Douglas function. And the price of apples is 2, the price of bananas is 3, and my income is 60. What should I do? So, what is my optimal consumption bundle given my income? So here I summarize the specifics of the utility function, prices and income. And we first draw the budget line. So let's do that. So we have apples and bananas, and if we spend all our income on bananas, we can buy 20. If we spend income of 60 on apples only, we can buy 30 apples. So this is the budget constraint. Now we throw in some indifference curve given by our Cobb-Douglas utility function. There they are. At the optimal bundle, the slope of the indifference curve and the budget constraint, they have to be equal. So we need to have that the marginal utilities are equal to the price ratio. We know from our utility function that the marginal utility of A is identical to taking the derivative of the utility function with respect to A. So plugging the 0.5 in front of the functional form, then reducing the power with 1, 0.5 minus 1 is minus 0.5 times b to the power 0.5. Similar marginal utility of b, and now we can divide the two. Nice thing about Cobb-Douglas is that a lot of terms cancel out, like the 0.5, and if we have the ratio, we can reduce this in a couple of steps, and I will go very slowly here, but in the end you arrive at the ratio b over a. And we've seen that before in the example. And the price ratio of the two goods is equal to 2 over 3, which means that at the optimal point, these two expressions must be identical. So we have marginal utility ratio has to equal the price ratio. We now have an expression for both. So we can solve for B. So what do we know? We know that at the optimal point, the number of bananas that this consumer consumes is 2/3 the number of apples that he or she consumes. But we have a second condition. The budget constraint has to be satisfied. We cannot buy 3 million apples and 2 million bananas because our income will not allow us to do so. And we use this information second. So we know that our total income is 60, price of apples is 2, and the price of bananas is 3. So we can buy only the bundles that satisfy the budget equation. 2 times A plus 3 times the number of bananas has to equal 60. So now we have two expressions with two unknowns and we can solve. So one thing that we can do is we can substitute the B over here with the expression that we found over here. So let's do that. And we get that on the left hand side we get 4 times A is identical to 60. Now we're almost there. It's not really hard to find out what the optimal amount of apples is in equilibrium. It's 60 divided by 4 is equal to 15. And once you know that in the optimum you consume 15 apples, you also know that you consume 10 bananas, because we know that the number of bananas at the optimal point is 2/3 the number of apples. So that makes 10. Okay, in doing this, I used a couple of mathematical tricks or rules, as you may say. So in taking the derivative, we use the rule that if you take the derivative of something that's in with a power, then it ends up like this. Although I must say, you should do a delta, a dA over here, and not a dx. And we use that the inverse of a to the power x can be written as a to the power minus x, and we know that a to the power x times a to the power y is identical to a to the power x plus y. Quiz. Similar type of problem, but now you need to do it yourself. Suppose that you consume artichokes and beans. Well, why these two goods? They start with the letters A and B. The utility function, hey, again, is a Cobb-Douglas function. The price of artichokes is 15, the price of beans is 10, the income is 200. What should I do? So what is the optimal consumption bundle given the budget constraint? Okay, if you gave it a try, then this is the outcome. So at the optimal bundle, the slope of the indifference curve and the budget line have to be equal. You get marginal utilities. You can simplify. You know the prices of the two goods, so you know the slope of the budget line. You equate the two, and you plug this into the budget constraint, solve for A, and you get an optimal solution that the number of artichokes is equal to 4 and the number of beans is equal to 7. This brings us to the end of the lecture on chapter 4. So what did we do? We first started with 4 assumptions about consumer preferences. They were light assumptions, but made our life much easier because they allowed us to express preferences in terms of a utility function. And then in the remainder of the lecture, dealing with utility functions, we found out that it's very handy because utility functions, you can do a lot of things with them, and they bring you to solving the consumer optimization problem. We brought in budget constraints. We looked at what happens to the budget constraints if you change income or the prices of the two goods. And then in the end, it all culminated in solving the consumer's optimization problem. Next week, we're going to deal with chapter 5. And chapter 5 is how do consumption choices change if the income changes, and how do the consumption choices change if the prices change. Because in the two examples that we did today, we had a fixed budget constraint. But next week, we will also look at what happens if the budget constraint changes, because one of the prices changes or because the income of the consumer changes. And we will also move from individual demand to market demand.